what are the key terms, whether it is light beam, uniform cross-section beam, weight, is it point, is it UDL, reaction or support, is it single point support or is it resting over a certain surface. So all those things is what is meant by careful reading. Then your first test lies on understanding the question is you make the correct diagram, the correct beam diagram. Once the beam diagram is made, then the next point was to calculate the reactions. Once the reactions are calculated, next is have a good look at the beam diagram and identify the key points or the minimum points at which you must calculate the shearing force in order to get the SF diagram. As I told you yesterday, we are talking of minimum points and nothing less than that would work. Anything more than that, provided you don't make any other mistake, is not an issue. Then we make the SF table, we complete the table. In making the table, we also take a call if any of the cells have to be divided into two. The sequence of the points in the table must be correctly taken. We had agreed yesterday that in normal discussion, in the normal course of action, we would prefer to go from left to right. That is what we had agreed in the class that yesterday. And when we go from left to right, then upward forces are positive and downward forces are negative. Needless to repeat, if under some situation, in some situation, if I have to go from right to left and makes my calculation easier, then these signs will stand to reverse. Once the SF table is made, then you'll decide on the scale of your SF diagram and then plot the SF diagram by first plotting the SF points that you have obtained in the table, and then the points need to be joined in correct order. And how will you decide whether it is straight line, not a straight line? It will all be governed by the beam diagram. So whether the points will be joined by a curve or a straight line. Now yesterday nothing came in curve, today also nothing may come in curve as far as SF diagram is concerned. But yes, for beam there can be a curve also. So what will be the shape, whether it is a straight line joining or a curve joining the 2 points, that will be guided by the beam diagram. Guys, any of these points which is not clear to you, this is all this we had executed yesterday. Any questions on these points on display? Are
No,
these
sir.
points well understood? And yesterday you could understand them when we solved the last question, correct, guys?
Yes, sir.
Okay. Okay. Now we'll take the first question that we took yesterday of a simple case. And now we'll try to understand the BM. It says draw SFBM diagram. SF diagram we have already drawn yesterday. But before we formally close it out, I'll first make you understand what is meant by BM at a point. Firstly, what is the full form of BM? BM is bending moment. But fundamentally, what is it? It's moment. You had taken moments when you are doing the reactions. So moment is what about any point? The weight or force involved multiplied by its lever from the reference point. So what is bending moment? It is a moment basically, right? So you know how to calculate the moment. So I'll make this diagram again yesterday, which we did. It was a light beam AB, 10 meters in length, supported over knife as supported the two ends, carrying a point force of 50 newtons at mid length and another 30 newtons 2 meters from end A. This distance was 2 meters, this distance was 3 meters, this distance was 5 meters. And obviously the total reaction was 80 newtons. We calculated these reactions, and this is what you had got. Am I right, guys? Correct, Peter?
Yes, sir.
Very good. Now, What was the shearing force diagram? I remember it, so I'll draw. You can look at your notebook about yesterday's work. The SF diagram for this case was like this: A, B. We call this point as C, and this is D. Midway is C. Somewhere here is D. This is 2 meters. This is 3 meters. This is 5 meters. And how did we draw the SF diagram? Let me use a blue marker. At A, it went from 0 to plus 49. Then it remained plus 49 up to B. This is SF in newtons. Then we came to plus 19 at D. Please correct me if I'm making any mistake, though I remember it clearly, but if there's any oversight, please correct. It came to plus 19. Then at C, it went to minus 31. It remained minus 31 and became 0. Was this the SF diagram we got yesterday, guys? Yes or no? This means?
Yes, sir.
Okay. No. You have to tell. I'll not take 2 points today. I'll take any one random point, whichever you say. But since we are going to calculate moments about that point, you'll have to give me its exact location in terms of distance from either A or B or C or D. Where would you like to take a point? Anywhere along the length? Tell me, guys. Between AD, DC, CB, where would you like to take a point?
Sir, at D.
Between
At
DC.
between DC, okay. At what distance from D, beta? It is 3 meters. So where would you like to? Because for livers, I'll need this exact location. Yesterday, I was not interested in SF, the liver, so that's why I didn't insist upon the distance of X. I remember you took X between D and C or wherever it was. Uh, but I did not insist on was not being discussed yesterday. Today we are discussing about moment. So can you tell me how many meters from D would you like to take the point?
2 meters.
2 meters from D. That means 1 meter from C. You want to take point X here, whereas this distance is 2 meters. This distance is 1 meter. Am I right, guys? Okay.
Yes, sir.
Now, what we'll do is yesterday when we were talking of shearing force, we took the we found the resultant of the forces to both sides of X. Today we are talking of moments. Now we will find out the moment of all the forces to the left of X about point X. So now you're taking moment not about A, not about B, you're taking moment about X. So that means levers will be from X. You already know how to take the levers. Now about X, first tell me, guys, is 49 newtons about X? Now we are taking moments about this point where I've made this square. Now about this point, is 49 newtons going to cause a clockwise movement or anti-clockwise movement? Can you visualize now in the diagram?
Clockwise.
It is going to cause a clockwise movement, correct. I'm sure you'll agree 30 newtons will cause anti-clockwise movement. Am I right, guys?
Correct, sir.
50 newtons will cause clockwise or anti-clockwise about X? Tell me.
Clockwise.
Clockwise. This will cause
Clockwise.
clockwise and this will cause anti-clockwise. Very good. So there are two forces on each side. What will be the moment of 49 newtons? I'm sure the lever is 2 plus 2, 4 meters. So the moment is 49 into 4, and this is in the clockwise direction. Am I right, guys? Correct?
Yes, sir.
How much it comes to 4 nines are 36, 3, 196 Newton meter in the clockwise direction. What is the moment caused by 30 Newton about X? It is anti-clockwise. It will be 30 into 2, but it will be anti-clockwise, guys. This is 60 Newton meter. Am I right?
Yes, sir.
Correct. So what is the resultant of the moment caused by the forces to the left of X? The resultant is, if I'm not mistaken, it is 136 Newton meter and this is in the clockwise direction. Am I right, guys?
Correct. Yes, sir.
Yes. Anybody has any questions on getting 136 Newton meter in the clockwise direction? If anybody has any questions, let me know. Anybody in the class, guys, wants to clarify? Is that okay? Okay. Can you please calculate, before I do it now, can you calculate the moment of resultant moment of forces to the right of x? Calculate and tell me how much is it. So that will also be a test and of whether you have understood or not. And how much is it coming, guys? Calculate and tell me, please. How much is it coming, guys?
Minus 136,
95
sir.
Newton.
136, sir. 136.
Minus
Name also,
Anti-clockwise.
direction also, but direction also. But
Anti-clockwise.
Anti-clockwise.
136 anti-clockwise. Okay, let's see. It's correct, but let's see if there's anybody's messed it up. There are two forces to the right of it. One is 31 newtons, which is causing anti-clockwise, and that will be 31 into 6 equal to 186 Newton meter. And this is anti-clockwise. We have already discussed this. And then you have 50 into 1, that is 50 Newton meter in the clockwise. This is clockwise. Okay, this is clockwise. And the resultant of these two is again 136 Newton meter, but this time it is anti-clockwise. Yes or no, beta? Am I right?
Correct, sir.
Everybody
Correct, sir.
agrees? Okay. Guys, something like this we had seen yesterday also when we were taking algebraic sum of the forces. The algebraic sum of forces on both sides of the point came same, only their directions were reversed. If it was upward on one side, it became downwards on the other side. And if it was downwards on one side, it was upward on the other side. Now, yesterday I took 2 points. Now you know what happens. So the same thing will repeat. If I take one more point anywhere or two more points anywhere, we'll see the same thing happening. What is the same? That numerical values of these moments will be same, whatever they may be. Not 136 necessarily, whatever they are at each point. But their signs would be reversed. If one side it is clockwise, other side it will be anti-clockwise. Okay. Now, this trend you will see everywhere at every point along the length. Okay. So what is this 136 Newton trying to do? Guys, any moment is trying to rotate the beam. You know, some moments are trying to rotate clockwise, some moments are trying to rotate anti-clockwise. I'll again come on the camera now, guys. I'm just okay. One second. I'll just come in the view. Don't worry. Okay, guys. Can you see me? Because the right
Yes, sir.
now again I have this marker. Let us say the line separating the black and the red one, the white and the black one is point X. Now you see, if I hold one side, now basically the moment is trying to rotate the beam. But if I hold this beam like this, then what am I doing? I'm preventing the rotation. And if I'm preventing the rotation, then what will happen? This moment is trying to, which was trying to rotate and now is not able to rotate because you have held, supported the other side. What will it try to do? It will now, instead of a rotating effect, it will have a bending effect. It will try to bend the beam here upwards with 136 Newton meter clockwise, right? Am I right, beta?
Yes, sir.
Yes or no?
Correct, sir.
Or if I do the other way, I hold it like this. If I do not support, this should be rotating the beam. if there is a resultant. But if I support like this, so this 136 Newton meter, this side is trying to bend it upwards because this is acting anti-clockwise. So basically, effectively, what is happening? This 130 Newton meter is tending or trying or attempting to bend the beam at X. Do you agree with me? If you agree, I'll put off the camera. If you have any questions, let me know before I go to the presentation. Is that okay,
Agree, sir.
class?
Yes,
Yes,
sir.
sir.
So what is this 136 Newton meter then? This 136 Newton meter is nothing but the bending moment at point X. Again, there's a problem with the signs. We had upward downward problem yesterday. If I ask the class what is the bending moment at X, some will do from left to right, some will go from left to right, and those who go from left to right will immediately answer me 136 Newton meter clockwise. Those who come from right to left, they'll again say 136 Newton meter, but they'll say anti-clockwise. So there will be an anomaly as far as direction is concerned. Numerical value would be the same. To remove this, like yesterday, again a sign convention is introduced. And what is the sign convention for bending moment? When you go from left to right, as you have done in this case, then clockwise movements are taken as positive, clockwise movements are taken as positive, and anti-clockwise movements are taken as negative. I don't have to repeat. The other side would be reverse. If you are coming from right to left, as for this particular case, then clockwise movement will become negative here, and anti-clockwise movement will become positive. So instead of saying what is the bending moment at X and somebody saying clockwise, somebody saying anti-clockwise, we'll talk in terms of plus minus. And now both sides will get, obviously, either both will get plus 136 Newton meter or both will get minus 136 Newton meter, whatever you get. So this is the sign convention introduced to basically harmonize the response from both the sides, to remove the anomaly of the sign. Okay. Now, guys, this bending moment, you see, from X, between X and Y, is there any change in the force? Between X and Y, is there any change in the force in the beam, on the beam? I've just marked Y also, guys. Between X and Y,
No,
is
sir.
there a change? No. Though there is no change in force, there may be a change in force, but here there is no change in force. But the bending, shearing force at X and Y will be same because there is no change in the force. But bending moment and at X and Y would be different because the levers will change, because with the shift of point, even if the forces do not change, the lever is definitely changing. Am I right, guys? Yes or no? The moment I take calculate bending moments about Y, I'll be taking levers from Y. Am I right, guys? Correct,
Correct, sir.
class?
Only
So
lever.
between X and Y, there is no new force. There is no change in SF, but BM will still change because the levers will change. So there will be some different value at Y. Look at this diagram, guys. Yesterday, did we decide to go generally? Did we decide to go from left to right or right to left?
Left to
Left
right.
to right.
Left to right.
So when I go from left to right, which forces are causing clockwise movement, downward or upward?
Upward.
Upward. This is the upward force which is causing the clockwise movement. This is a downward force causing anti-clockwise movement. So we'll try to go as much as possible left to right only, unless in some case we find going from left to right is increasing our workload. Then we might change from right to left, and then we'll tell ourselves, boss, the sign convention needs to be reversed. But if we are able to manage from left to right, then we know that upward forces in SF were positive, downward forces were negative. And we also see that upward forces are causing clockwise movement. That means plus forces in the shearing force are causing plus bending moment. Am I right when you are going from left to right?
Right.
Correct, class? Now, guys, this is what bending moment is all about. It tends to bend the beam at that particular point with whatever is the bending moment. Now, whether the beam will bend or not, that will depend on the strength of the beam. Beta mute kar lo, Som Patel, please mute yourself. He's muted. Somebody else is not muted. Can you mute yourself, please? Now, the beam will bend or not will depend on the scantlings of the beam, the strength of the beam. If the beam is not strong enough, it will bend. If it is strong enough to withstand that bending moment, it will not bend. But now the problem here is every millimeter shift of point, even if the forces don't change, the levers will change and calculating bending moment will become a very cumbersome process. So we can do it this way, the way I have explained, but it is not going to be user friendly. Now I would like to draw your attention to the SF diagram. In the SF diagram, where is point X? Point X is here. It is 2 meters from D and 1 meter from C. Now, guys, see how much is the area under the SF diagram to the left of X. To the left of X, you have this area and this area. Correct, beta? Am I right?
Yes.
What is the area under the SF diagram to the left of X? It is 49 plus 49 into 2, and then another is plus 19 into 2. Do you agree this is the area under the SF diagram to the left of X?
Yes, sir.
And what does it give you? It gives you plus 136 Newton meter. Why Newton meter? Because this is in newtons and this distance was in meters. So what do we see? Whatever we calculated at X can be easily obtained from the SF diagram by integrating the areas under the shearing force diagram. Correct, beta? Yes or no?
Yes, sir.
So, getting the BM by use of SF diagram is much more easier and convenient compared to BM diagram. And what do we see in this case? We had gone to X from left to right. And what did we see? Plus shearing force gave plus bending moment. Minus shearing forces would have given minus bending moment. So when you will go in the shearing force diagram from left to right, as we have agreed, plus shearing force will result into plus bending moment. So it makes the life even more easier. But guys, please remember, if you decide under any circumstances to come from right to left in your shearing force diagram, then plus shearing forces will result into negative BM and negative shearing forces will result into positive BM because the sign convention will reverse when we move in the opposite direction. Yes or no? Correct, beta? Correct, class?
Yes, sir.
Yes, sir.
Okay. So normally we will use the SF diagram, and that is why I was saying that if your SF diagram is wrong, then your BM diagram cannot be correct. And therefore, SF diagram is what where we spent the full session yesterday before bringing in BM today. So we will not be calculating at each point this damn thing BM by multiplying forces with the levers. Instead, we'll be using the shearing force diagram and we'll get the BM at sufficient number of points and then we'll draw the BM diagram. Guys, more details of how we draw we'll discuss when we do this with SF diagram. But whatever I have said, if any part is not clear, please let me know. I'll be clearing this, whatever is on the board now. If anybody wants to take any screenshot, anybody wants any clarification on it, please let me know. Is it clear, class? Bolo bhai?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so I'm clearing the screen then, guys. Okay, I can go to the next one. Why honestly clear it? Leave it. Okay. Now draw, this is the same question, draw both SF and BM diagram. Okay. Guys, do I need to take you through again the SF diagram? Yesterday we have done it twice. Do I need to spend time on it? Tell me. If it is required, then I can do it again. Or
No,
can
sir,
I
no.
straight away draw the BM diagram? Tell me.
Just
Anybody
straight
who
out.
straight BM diagram. Okay. So guys, anyway, I'll not make the SF diagram this thing, but I'll straight do the steps. First step is to make the beam diagram. So we make the beam diagram. After drawing the beam diagram, sorry, we calculate the reactions and we got reactions as Ra 49 newtons and Rb 31 newtons. Second step. Third step was to identify the points where we must calculate the SF. And based on our learning yesterday, it is minimum 4 points. We named the other 2 points. Two are already named A and B. And yesterday we named these points as C and D. Then we made the SF table for these points. And let me make the SF table quickly. It will not take time. SF table here. And we made the SF table for 4 points, guys. We put the SF units here. Be careful. We put the points in the same order as they figure in the beam diagram, which in this case is A, B, C, D. We look at the beam diagram and figure out which all points have the point forces. And we find that all these 4 points have the point forces. So we divide all these cells into two. Then we start moving from left, just to the left of A. This is how I talk to myself. Just to left of A, shearing force is 0. I carry forward this 0 and I move from just to the left of A to just right of A. Plus 49 comes into picture and shearing force becomes plus 49. I carry this plus 49 and look at the beam diagram. From right of A to left of D, there is no new force. So it remains plus 49, or you can say plus minus 0. It remains plus 49. I carry forward this plus 49 from just left of D and move to just right of D. Minus 30 comes into existence, making it plus 19. I carry forward plus 19 and look at the beam diagram. There is no new force coming between D and C, so plus minus 0, it remains plus 19. So whether you write plus minus 0, I have written at one place, other place I have not written, just to tell you that whichever way you feel comfortable, you could do it. We carry forward plus 19 and then minus 50 comes into force. It becomes minus 31. Then it remains minus 31 just to the right of D. We carry minus 31 and then 31 plus comes into picture, and this is the SF table. Based on this SF table, let's make the SF diagram. We'll calibrate the scale accordingly, guys. I will not spend time on calibration. You know it. So, you know it. So I'll just draw the SF diagram. At A, I'll use the red marker so that with the axis there is no confusion. At A, it goes from 0 to plus 49. Then it remains plus 49. Then it becomes plus 19, remains plus 19, becomes minus 31, remains minus 31, becomes 0. Everybody is good up to the SF diagram class?
Yes, sir.
This is what we did yesterday, right? Okay. Now, guys, the job of the beam diagram is over. The job of the beam diagram is over. Now your entire focus shifts to SF diagram. Is that clear? Now you will only look at SF diagram hereafter. Okay, beta? Okay. Now you look at the SF diagram and identify the key points for BM. What did I say? I'll repeat. Look at the SF diagram and identify the key points for BM. And how do you identify the key points for BM? For BM table, there are only two simple criteria. One, all SF points to include. In addition to that, additionally, take points where SF diagram crosses the or cuts the x-axis. So other than all the points taken for SF, please also include any additional point at which the SF diagram may have crossed the x-axis. Have you understood these 2 points, or anybody wants any clarification? Tell me. Have you understood what I said, guys?
Yes, sir.
Yes.
Now, based on what I said, how many minimum points should I take for the BM table now? Tell
Four.
me. 4 only?
Yes, sir.
Because it is not crossing at any new point. So we had 4 points for SF, so 4 points will continue for BM. Now you see, what am I writing? BM table. What am I writing in the bracket? I'm not calculating by livers. What am I doing? By areas under SF diagram. So how am I taking BM? I'm calculating it by SF area under the SF diagram. When you make the BM table, the order of the points must be same as in the SF diagram. Now I said you have already left the beam diagram behind. Beam diagram has its job done once you have got the SF diagram. So beam diagram is guiding you only up to SF diagram. After the SF diagram is obtained, for BM diagram, it is the SF diagram and only the SF diagram which will guide you. So we make the BM table for 4 points. So 1, 2, 3, 4. Now, once this division of the cells into 2 only happens in the first table that you make, and first table you made was SF. In BM, there will be no sudden change of area. Area will not suddenly change from 50 to 30 or 30 to 20. No, it will gradually change whatever happens. So there will be no further subdivision of the cells at all. No consideration required of that. I write the points in the same order, pay attention wisely, as they figure in the SF diagram. And in the SF diagram, they figure as A, D, C, B. I write BM here and I write the units of BM. What will be the units of BM? Units of BM will be product of unit of shearing force and unit of length of the beam. In this case, it will be Newton meter. Okay. Now do the same thing. If you have that piece of page that you tore off yesterday, just see how much area is under the SF diagram to the left of A, guys. Cover up to A, right side up to A, and see, is there any area under
Zero.
the SF diagram to left of A?
Zero.
Zero.
Zero. Zero.
Zero. So the bending moment at A is 0. Now we'll keep carrying it forward and keep applying the change instead of every time starting from the left hand. And I told you we are going from left to right. So positive SF will give positive area, positive BM. Negative SF will give negative BM. Why? Because we are going from left to right. If we reverse the movement, these signs will stand to reverse. Please remember. I carry forward the 0 and now I move my paper to D. What is the new area that is exposed from A to D? I'm sure you'll
49
agree
into 2.
it is plus 49 into 2. This
Into
write
2.
down here 2 meters,
98.
3 meters, and 5 meters. Plus 98, not 98, plus 98. Don't say that absence of sign is positive. No, please be very explicit in writing plus. Okay. Then I carry forward this plus 98. Why? Because up to D plus 98 is already calculated. Then I shift my paper to C. What is the new area uncovered? Plus 19
19
into
into
3.
3.
57. So it will become plus 155. Am I right, guys? Okay. I carry forward this plus 155 and then I move my paper from C to B. What is the area uncovered? It's minus 31 into 5, making the BM at B0. Correct, beta? Everybody
Yes,
has
sir.
understood how the BM table is completed before we make the BM diagram, guys? Please let me know if there's any concern. Class,
Yes, sir.
tell me,
Clear.
guys, clear? Okay.
Yes, sir.
Now, yeah, now we'll go to BM table and plot the points, and the shape of the BM diagram will come from the SF diagram. Where did the shape of the SF diagram come from? It came from the beam diagram. So beam diagram was guiding you to shape the SF diagram. Now SF diagram will guide you to shape the BM diagram. So now we have the BM diagram here. We have only positive values, so I don't need anything below the x-axis. So I don't have to have anything below the x-axis, guys. A, B, C, and D. This is 2 meters to a scale. This is 3 meters to a scale. This is 5 meters to a scale. This is BM in which units? Newton meter. Since I need up to plus 155, so let's say 50, 100, 150. So let's say 150 plus 100 plus 50. Now I'll plot these points first and then we'll decide how do we join them with. How do we join them? Because points can be joined in different ways. They can be curves, they can be straight lines, and curve can have different curves. At A, it is 0. At D, it is plus 98. At C, it is plus 155. And at B, it is 0. Now, guys, I have to join A and D, the values of BM. Look at the SF diagram. Look at the SF diagram. Guys, is the area under the SF diagram changing at a uniform rate from A to D or not? What do I mean? If you divide this into equal on the x-axis, is the area of each rectangle same? Yes or no, guys? Am I right? Correct? Is the area same, guys? If on the x-axis these gaps are same, then will these areas be same, all of them? Yes or no? Tell me.
Yes, sir.
So that means if I uncover my, let me just take the 1 second. Keep it as it is. I should not delete it. Yesterday by mistake I deleted. See, guys, if I let me use this only, no problem. Now, guys, you see, if I move from here, this is the change in area. If I move the same distance, is the change in area the same? Yes or no? Correct? Am I right, guys?
हाँ जी सर.
Yes, sir.
If I keep gradually uncovering, is the change in area happening at the same rate? Yes or no? Rate is same. Am I
Yes, sir.
right? For every 1 millimeter or every 10 millimeters or every half a centimeter or every 1 centimeter or every 1 meter or every half a meter, is the area increasing at the same rate? Yes or no? Am I right?
Yes, sir.
Correct, class? Have you understood, guys? Anybody in the class who has not understood? Because I'll be deleting the blue box and going into PowerPoint presentation then, because I can't move it in the PowerPoint presentation, guys. So does everybody agree that the area from A to D has increased at a uniform rate? Yes or no? Rate of change of area from A to D is at a uniform rate. Does everybody agree? Class, tell
Yes,
me.
sir.
Yes, sir.
Yes,
Yes.
sir.
And if the rate of change is uniform, then what is the shape of the graph? If the rate of change is
Straight line.
uniform, what is the shape of the graph?
Increase.
It will be
Straight line.
Straight line.
straight line. So that means from A to D, my BM will be a straight line. So I'll put my scale between 0 at A and plus 98 at D, and I'll join them with a straight line. Let me use a green marker only so that. So I had a look at the graph SF diagram from A to D, and I decided on the shape to be straight line. Now I go again back to the diagram, SF diagram between D to C. Please tell me, is the rate of change from D to C say uniform? Yes or no?
Yes, sir.
Yes.
Uniform.
Yes, sir.
So
Uniform.
again, I keep my scale at plus 98 and plus 155, and I join them with a straight line. Now I go to the SF diagram between C and B. Is the rate of change uniform? Yes or no?
Yes,
Yes
sir.
sir.
So I keep my scale at plus 155 and 0 at B and join them with straight line. All these lines are exact straight lines, and what you have got in green is the BM diagram for this question. And this question, which we started off with yesterday, now comes to an end with having seen both BM and SF. So we have three diagrams. We have the beam diagram, which was guiding us till we got the SF diagram. Then SF diagram took over and led us to BM diagram. Please evaluate this for next 10 seconds and let me know if you need any clarification. Guys, any doubts? Please let me know. Are we good, class?
Yes, sir.
Okay. Okay. Now we'll go to and look at the BM diagram for the second question, that second SF diagram that we had drawn, uniform cross section being supported at the two ends. Done one. Now we'll do two, and then we'll move on to the questions from the sheet that I have shared with you. A 10-meter long beam AB of uniform cross section weighs 50 newtons. It is supported over knife edge support at both the ends. Draw its SFBM diagram. Guys, SF diagram we had drawn yesterday. So what I'll do is I'll draw the beam and draw the SF diagram. And if anybody has any questions up to SF diagram, please do let me know immediately. And then we'll just focus on SF diagram and try to draw the BM diagram. Yesterday, guys, we had drawn this beam like this of uniform cross section. AB, length was 10 meters, weight is 50 newtons, which is distributed at a uniform rate of 5 newtons per meter. It was supported on knife as support at both the ends. And then we calculated the reactions. We got RA as 25 newtons and RB as 25 newtons. Am I right, guys? Yes or no? Correct, class? So far, so good, guys. This question
Yes, sir.
we had done yesterday, right? Then looking at this, all of you said many of you said 2 points. So today I'll make the SF table with only 2 points, the minimum number of points. Yesterday I intentionally took the third point. Okay. But if somebody takes the third point, that's fair. No problem. Now I take it for SF table and I'll make it only for 2 points. We had discussed it in detail yesterday. I'll make it for A and B. SF units will be newtons. Left to right is AV. At A and B, we have point forces in the form of RA and RB. RA and RB are point forces, so both A and B will be subdivided. Now, what is the shearing force just to left of A is 0. We carry forward this 0 and then we have plus 25 coming into picture. This will be plus 25 here. We carry forward plus 25 and we move from just right of A to just left of B. And we have 10 meters of beam weight coming into picture. That means minus 5 into 10, making it minus 25. Then we carry forward minus 25, and then we have plus 25 coming into picture, making it 0. Is making of the shearing force table clear to everybody, or anybody has any questions to ask? Class, please tell me.
Yes, sir. Clear.
Okay. Now, we will make the SF diagram based on this, and then we'll move on to B. We have this plus minus 25, so we'll have both below and x-axis and above x-axis. We have A and we have only 2 points B. This is shearing force in newtons here. We take plus 25 at some distance, whatever we want, and same distance I take minus 25. Now at A, it goes from 0 to plus 25, and at B, it goes from minus 25 to 0. So we have 0, we have plus 25, it goes here. Then we have minus 25, and then 0. 0, this is minus 25. Now we have to join plus 25 with minus 25. For the shape, we look at the beam diagram, and the change from plus 25 to minus 25 is propelled by the weight of the beam. It's basically because of the weight of the beam. And the weight of the beam is changing uniformly with its length. Therefore, yesterday we discussed plus 25 and minus 25 will be joined with a straight line. Correct, beta? Yes or no? Am I right?
Yes, sir.
And this red one is the SF diagram of the beam. Anybody has any last minute questions on SF, which we did yesterday, guys? Now we go to the BM table. How are we going to make the BM table? By areas under SF diagram. How many points should we take now? Look at the SF diagram and tell me the
Three.
number of three.
Three.
Yeah, it is cutting at a, so we have 2 points for the SF. Both those points get qualified, and it is additionally cutting. Those who would have taken that point, what automatically 3 points would have continued. So BM in Newton meters, 1, 2, and 3. Now, guys, since this point has to be included in the BM diagram, we'll have to name it. And you know, since it's plus 25 and minus 25 and joined by a straight line, so obviously the 0 will come mid-length. So that means this will be 5 meters and this will be 5 meters. Am I right, guys? Does everybody agree or anybody has any questions?
Agree, sir.
Okay. Now, my points will come in the same order as they are on the SF diagram. And in SF diagram, they are in this order. Now we do the same thing. I ask myself this question: what is the area under the SF diagram to left of A? Answer is 0. I carry forward this 0 and then I ask myself, what is the change in area from A to C? It is the plus triangle. So it is plus area of a triangle is half, whose base in the diagram is 5, height is 25. So this is the area of the triangle, guys. And this becomes plus 62.5. Am I right, guys? Correct, beta?
Yes, sir.
Anybody has any questions how the BM at C has come? It's the formula for area of a triangle. Base is 5 meters, height is plus 25, and that becomes plus 62.5. We carry forward plus 62.5, and then change from C to B is the negative triangle. So minus half into 5 into 25, making it 0. Yes or no, beta? Tell me. Correct, class?
Yes, sir.
Now we are on to making the BM diagram. Guys, I'll give you 5 seconds to review the BM table if anybody has any questions. BM diagram. I have only 1 plus 62.5. So I don't have to have anything below the x-axis. Why unnecessarily compromise on the scale? I can use a bigger scale if I don't need anything below the x-axis. This is A, below it here is B, and midway between these two is C. And when again you have to plot one value, don't break your head. You can mark anywhere and mark it like this. Now I'll plot these values. At A, it is 0. At C, it is plus 62.5. At B, it is 0. Now, I have to join A with the value at C. Look at the SF diagram and tell me, is the area of the triangle or plus triangle changing at the same rate from A to C, or is it not changing at the same rate, class?
Not
Not
changing.
changing.
Not changing, sir.
Very good. It is not changing. So that means A 0 and 6 plus 62.5 will not be joined by a straight line. They will be joined by a curve. You are integrating areas under a slanting line, and when you integrate areas under a slanting line, you'll get a curve. Okay. Now, curves can have different shapes. There can be infinite curves that you can draw between 2 points. So, how do I decide on the shape of the curve between A and C? Let me just explain out here. Guys, when you get triangles, please, you can calculate and see. Now, we'll be talking of the triangle we can have the triangle in two forms. One, you may have a condition like this. That means you are going from this side to this side. When you go like this, we'll say we are integrating from base to vertex. Why? Because you're moving from base towards vertex. Or the triangle may be like this, and you're integrating like this. Then we'll say we are integrating from vertex to base. Is the a call between base to vertex or vertex to base clear? Am I clear, guys?
Yes. Yes, sir.
Now you see, guys, here initially the rate is more. This one, this trapezium has the maximum area. This has lesser than 1, then lesser than 2, and it is getting lesser and lesser and lesser and lesser and becoming 0 at the vertex. When you go from vertex to base, initially the rise is slow, increases at a slower rate, and the rate keeps increasing as you go towards the base. So that means, and guys, whenever the more, rate is more, the curve will be steep. Whenever the rate is less, the curve will be closer to horizontal. Okay. So guys, if you have this, the curve will come somewhat like this. If you have the base here and the vertex here, and let us say the total area of the triangle is here A, which was 62.5 in our case. Initially, the rate of increase is more and it is becoming nearly 0 at vertex. So it will rise like this. This will be the shape of the curve when you're doing from base to vertex. If you're doing from vertex to base, the total area is A here. Initially, the rate is lesser, like this. It is lesser and then it rises as I reach A. It will be somewhat like this. Can you appreciate the difference between the two curves, beta? They are not same. Am I right?
Yes, sir.
In first case, initial rate is more and the rate is gradually decreasing. Here, the rate is less and it is progressively increasing. So if you are doing from base to vertex, the curve will come like this. If you are doing from vertex to base, the curve will come like this. Now, some of you may struggle to give it shape, but once you practice, you can give. I'll also introduce another property of a triangle. If you take any triangle, and you take the midpoint of the base, then what does it do? It divides let us say the bigger triangle has area A. Bigger triangle has area A. This perpendicular at half of the base divides it into area 1 and area 2. What is the shape of area 1, guys? So this is B by 2. This is also B by 2. What is the shape of area 1?
Triangle.
Triangle.
And what is the shape of
Triangle.
area 2?
Trapezium.
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 Right?
Trapezium.
So if you can use the formula half base into height and do it yourself, then you'll find that area of this triangle A1 will be only 25% of the total area of the bigger triangle. And the area of the trapezium will be 75% of the area of the full triangle. You can calculate and see. The full triangle will have area half base into height, and this is h. If this is b by 2, it is 0 here, it is h here, so this will be automatically h by 2. Guys, what is the area of triangle A1 then? It is half. Base of triangle A1 is b by 2. Height of triangle 1 is h by 2. It becomes 1 by 2 into b into h by 4. This becomes 1 by 4 into half b into h. What is half b into h, guys? Look here. What is half b into h? Is a? Yes or no? Half b. The area of the bigger triangle is how much? Half base, full base is B into height is H. Correct, beta? Yes or no? Am I clear, class?
Yes, sir.
Yes.
So what does it give you? Area 1 is 1 by 4 of A. So whenever you divide the triangle at the middle point of the base, the triangular part will be only 75% of the total, 25% of the total area, and the trapezoidal part will be 75% of the total area. I'll use that property and you see my graph would be more or less okay, may not be exactly okay, but you see this is 62 point, in our case, let us say this is A, whatever it is. Now, if I divide this A into 4 equal parts, each part represents 25%. Correct? Okay. Now, if I go to the mid of the base here, then see guys, where am I coming? Am I coming nearly at 75% of the area? Yes or no? Correct? Yes or no? Do you see that?
Yes, sir.
At the mid of the base, my trapezoid, from this side to this side up to mid base is the trapezium. Correct, guys? So it will be 75% of the total area. Correct?
Yes, sir.
And if I do the same thing here, this is A, I divide it into 4 parts. And I go to the middle of the base. How much area have I covered? About 25% only. Correct, beta? Am I right, class?
Yes, sir.
So those of you who have problem can also use this property of a triangle to shape the diagram. But if you are if once you gain confidence, you can quickly get the shape by yourself. There's absolutely no problem. Have you anybody has any questions before I go to the question where we have to shape the BM diagram, and we'll use this property to shape the BM diagram, guys. Anybody has any questions?
सर
Yeah,
हेलो
tell me.
सर एक बार ये जो आपने आखिरी में ये प्रॉपर्टी का एप्लीकेशन कर्व पे लगाया आप प्लीज एक बार समझा देंगे
Left triangle में, if I go to the middle of the base and I'm integrating areas from left to right, so when I reach the mid base, am I going to get the area of the trapezium or triangle if I'm going from left to right in this diagram?
ट्रेपेजियम सर
And trapezium area is how much? 3/4 of the
ऑफ द एरिया टोटल
area of the triangle A, correct?
यस सर
And you see, I drew this graph without plotting it, but you see, when I go to the mid base, what is my area coming? It is coming 75% almost. If I divide
sir.
A into 4 parts, each part is 25%.
यस सर
On
अंडरस्टूड
the other hand, if you see, if I go to the midpoint and I'm going from left to right, what area have I covered? Triangle to the
Yes, sir.
midpoint.
शुड बी
That
वन
will be only 1/4 of it.
अंडरस्टूड
That is why the shape of the two curves is totally different. Correct?
या करेक्ट ओके
And we can use this property to shape. I'll do it on the other thing. Anybody has any more questions out here? Please let me know. I'm going back to the slide of shaping the BM diagram then. These small things, if you keep in mind, then you can run away with the question in shortest possible time because you're using minimum points to calculate. Now let's come to shaping it here. Tell me from A to C, I'm just asking you, are we integrating the areas from base to vertex or vertex to base? A to C.
बेस टू वर्टेक्स
Base to vertex.
Very good. So you know what will be the shape of the curve. The curve shape will be like this. Correct, beta? Am I right?
sir.
I'll use this property here and see shape it. Those of you who not understood. I have taken 62.5 randomly, whatever my scale permitted. Now divide this space into 4 parts with a light pencil. It is for your guidance only. Now guys, don't do anything on the diagram. If I go to the midpoint, from A to this midpoint, is my bending moment will be the area of the trapezium or area of the triangle, small triangle? From A to midpoint, will the
Trapezium.
bending let us say, let me call this point as X. What will be the bending moment at X? This is 2.5
Trapezium, sir.
meter. It will be the area of the trapezium. And area of the trapezium will be 75% of the total area. What is the total area of the big this triangle? 62.5. So at the mid length, guys, this will be 75%, correct? And when I join these 3 points, this is X. You see the shape automatically comes what I had drawn. Am I right, guys? It automatically takes that shape, correct? Correct?
Yes, sir.
Have you understood why the shape has come like this? Am I clear, class?
Yes, sir. Clear.
Now, from C to B, is it vertex to base or base to vertex?
Vertex.
Vertex to base.
Okay. Now, if I say from C to B is a mirror image of this diagram, many of you will initially get confused. So what I'll do is, tell me, if I am integrating from B to C, B is here, C is here. If I'm integrating from B to C, is it vertex to base or base to vertex?
Base to vertex.
So that means beta, that means from C the area at Y will reduce by 25%, or from B to Y the area will be 75%. That means this point here at middle of this would be somewhere here. Yes or no again? Am I right? Correct, beta? C to Y, how much will be the area reduction? 1/4, na? Correct, beta? So from 62.5, this is 1/4. Correct? It will reduce by 1/4. Am I right? Correct, beta?
Yes,
Correct,
sir.
sir.
Because this triangle is negative. This will start reducing the area, na? Yes or no?
Yes,
Yes,
sir.
sir.
And again, or if you want to draw from B to C, draw from B to C, doesn't matter. So it will be a mirror image. Whatever this curve on this side is, the mirror image of this will be on the other side. Exactly the same, it will continue, and you'll get a curve, which is your BM diagram. Guys, I'll take a pause here if anybody has any questions on shaping the BM diagram. So it is not necessary that SF diagram and BM diagram should always be straight lines. No. It will always be governed by SF diagram shape will be directed by the beam diagram, and BM shape will be directed by the SF diagram. Now you can review it and let me know if you have any questions to clarify. Let me know if you have any questions.
So, excuse me.
Yeah, tell me.
Yes, sir. Like for the examination point of view, I mean, these diagrams have to be very big, or because the one I drew now is little small. I have taken the
Better
y-axis.
that depends. That depends actually. That depends. Like this one is straight and simple. This here the scale does not matter much. But there may be if you have to pick up some values, then bigger the scale, lesser will be the errors. Smaller the scale, more will be the error amplified. Right? The basic graph drawing techniques. Right?
Yes, sir, I'm little weak in it. That's why I was just asking, sir.
Yeah.
Thank you.
So it will depend. It will vary. Like in this case, this will suffice. That is not an issue. But in some other case, it may not be because if somebody says, what is the value at so and so point? So the smaller scale you would have used, more will be the error in reading the values from the graph then, right?
Yes, sir.
So it is a need-based thing, but always go by whatever reasonable scale you can use. And reasonable is difficult to define honestly. Why? Because it will vary from case to case. So I think as you do more questions, you'll have the hang of it, right? Otherwise, we can discuss it towards the end of the topic again if you still have an issue.
Okay, sir. Thank you.
Okay. Guys, if we are okay with this, now we'll start going to SF diagram of a beam, and I will be prompting you one step at a time. Please execute that step, wait, then you execute the next when I tell you, and then identify which step are you having problems, if at all there is a problem. And if there are no problems, fantastic then. So please, I will identify the problem area, if any. Guys, this is MMD question, and that should give you, we'll start with some confidence to you, so that with MMD point question having been done, you will be more comfortable in. Now, guys, in all my questions that I have done, what unit of force did I use? I used Newton, which is the correct SI unit of force. That is a SI unit of force. Newton, kilonewton, they are correct technically force. But guys, in chip stability, if you see pressure, which is as per physics should be newtons per meter square, or weight, which should be in newtons, we use, we call mass as weight. We say weight of the ship is in tons. We say the pressure is tons per meter square. So we take a lot of liberty of putting g aside, acceleration due to gravity aside. So the same thing you see here is given this time the weights in kgs. Okay. So like if I can express pressure in kg per meter square, then I can express my shearing force and bending moment also in kg and kg meter, or ton meter. Now, how will you decide, should you convert it to Newton, kilonewton or not, or should you use them as it is? Now, if the values are like this, rounded off values, as in this case, 112 kg, 13 kg, they are complete rounded off values. Directly use in kg or tons, whatever they are given. When the next question comes, I'll tell you if they are given in some fractions, then you could check. Maybe conversion to Newton or kilonewton will make it easier. So whether we'll convert them to Newton or kilonewton is not mandatory. We'll take a call based on what gives us more convenient values. And in this case, I'm sure you'll agree. If I multiply 1.112 by 9.8, it will convert into a very uncomfortable figure to handle. Likewise, if I multiply 13 kg with 9.81 to convert into newtons, it will basically convert into a discomforting figure. So in this case, I don't see any reason why we should struggle to change them and make things difficult for ourselves. Have you understood, guys? Have you understood?
Yes, sir.
So in this case, we'll continue using kg for shearing force, and kg meter will be the unit of bending moment. Now, guys, can you make this diagram, please? First step, make the diagram. Make the diagram. I'll follow after 30 to 40 seconds. Guys, don't wait for to copy from the board. If you keep waiting for copying from the board, you'll be harming your interest. Draw it. It's a MMD question, so it will also give you the required confidence that whatever you've understood is. Guys, have I made it correctly, or rather, have you made it correctly, or any one of have missed out anything, either at my end or your end? You can correct me also if I'm missing out anything.
So this 2.55 also needs to be marked.
No, not necessary. That is the, you can answer later on. Not no need, beta. Don't complicate here. You can just, after drawing the curves, you need the answer, right?
Yes.
Correct? Yeah. Is this the diagram everybody has drawn, class?
Yes,
Yes or
sir.
no? Okay. Let's name these 2 points as X and Y. for sake of uniformity. Can you please calculate Rx and Ry and give me the values? And if
R1
anybody
is
is
75, RX
50
R1,
50.
kgs. RX 50 kgs.
okay, Ry 75. I'm waiting now. Don't worry, I'm not rushing with the. So anybody who's not calculated, please calculate. If you're not getting the values, let me know. Second step is to get the reactions. If anybody is not getting the reactions correctly, I give you 30 seconds, 30 to 40 seconds to get the reactions. And if you don't complete in that time, you have to unmute and give a shout for further time. Okay, anybody in the class who is yet to get the reactions, please unmute and give me a shout. Anybody in the class, beta? Everybody has got fantastic. Now, the
I
next
know
step,
that I haven't got. I'm still calculating, Samuel.
calculate and please confirm. Yes, Samuel, how much?
Yes, sir. Got it, sir.
How much have you got? On the right side support, how much? At
Right.
Y?
RD. Okay, yeah. 75.
75. Let's left support now, mind if you named it differently, that's fine. Left support, how much is it the left support, Samuel?
50, sir. 50.
50. Okay. Anybody else in the class, guys? Okay. Now, guys, look at the diagram and tell me only the total number of points which must necessarily be included in the SF table. Give me 1, 2, 3, 4, 5, 6, 7. Count. How many minimum points should I include in the SF table, class? Give me a count.
3, sir.
3. Okay. Which 3, Ali?
Sir, X,
Huh?
Y, and the point weight. Let's say L.
And what was the criteria for choosing the points? Can you repeat the criteria for choosing the points?
In total 5 points.
Sir, at the endpoints, and at the point forces, ये दो था sir, और there was a third one. Just a moment. At a point where any uniform force changes.
Based on these 3 conditions, you see only 3 points. That's my question
5
to you.
points, sir. 5 points.
Who else said 3 other than Ali? Who said 3, guys?
I said, Akash, I said.
Akash, be careful here. Correct? The
Yes, sir.
thumb rules are very clear, na beta? Why are you missing out? Does everybody agree there are
Correct.
5 points? 4 are already named. Let's name it as C. If you've named something differently, it's okay. But only thing is, if we same name, then we can correlate the answer straight away. Otherwise, you'll have to do the mapping. Can you now make the SF table for the 5 points class, please? Make the SF table. I'll make after a while. I'm just making the structure of the table. I'll not put anything on it. Write the units of SF also. Please fill up the SF table. I'm taking a pause here. We have invested sufficient time in fixing the roots, and now it should not be an issue. You should be able to support yourself. Guys, are these the values of the SF that you have filled in? If you have any issues, please let me know. I have also parallelly completed the table now. And let me know if you have these values. I am underlining the SF values in red. If anybody has any issues, you can let me know. Who all have got it right? Can they confirm?
Thank you, sir.
Okay, Akshay. Anybody else who's got them right without looking at the board, please? And where, if you have made mistakes and you want to discuss or own it, it's up to you as to what did you miss out. Okay, class, final call for people to tell me if they want to share whether they are right or wrong. Else I'm continuing.
Done, sir.
Done.
Done.
Okay. Done. Anybody who's struggling, last opportunity to clarify. No? Okay. Now, please make the SF diagram. If you are not sure, make it in rough. If you are sure, you can make it here. If you are not sure, make it in rough. But do make it. Don't wait for uh, it to be drawn on the board, because if you draw, then only you'll be able to either endorse your work, or you'll be able to correct it, rectify if there's a problem. Is this the SF diagram you made, class? Yes or no?
Yes, sir.
All the changes are either because of point forces or the weight of the beam, which is uniformly changing. So all segments will be straight line, either vertical at the point forces or straight line slanting when it is because of the beam. So this is the SF diagram, class. Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay, very good. So half the question is complete. SF diagram is done. Okay, if anybody is still drawing it and wants me to wait, please unmute and give me a shout. Samuel, you are done?
Yes, sir. Done.
Okay, very good. Very good. Now, guys, can we please find out if these 5 points are good enough for the BM table, or do we need any extra point? Tell me.
Extra points, sir.
Where?
Extra one.
When it
extra.
is crossing x-axis.
So
Where?
before 7.
Between which
Before C.
points? Before
Before
C.
C.
Okay,
X and
okay.
C.
C and X.
Okay. Okay. Let's
X
call
and
it
C.
as Z. Okay.
What about this other point given in question, sir? Do we need to include that also?
Which one?
This 2.5 mm from a meter from B and end B.
This question was already asked when we started, no, Samuel? And I said there's no point why you want to clutter. This question was asked when we started the question, beta. When I made the beam diagram, somebody asked this question.
Yes. But I thought that was regarding the beam diagram. I was asking regarding the SF.
No, no, he needs values, no? Don't worry. Okay. Okay.
Okay.
Now, guys, for getting the areas of the triangle, we'll need the distance x to z and z to c. Now, guys, if the graph is very complex or something, then we can read it from the graph, because graph is made for further use. But what happens is, since we are making a very small diagram, as somebody was asking me about the scale a while back, if scale is small, then misreading z, because you will have least count constraints, maximum you can read maybe up to 1 decimal place, and then that will have a cascading effect in calculating areas or the BM. So in such simple cases, you can immediately calculate mathematically up to 3 decimal places ZC and CY. This is XZ and ZC. You can immediately calculate. How do you calculate, guys? Guys, the values are changing from plus 36 here at X to minus 6 at C at a uniform rate. So how much is the change from plus 36 to minus 6 here? How many units is the change, class?
42.
42.
42.
And over how much distance? What is the distance between X and C?
6 meters.
Okay. So guys, and it's a straight line. Therefore, we can use unitary method. Over 6 meters of distance, or rather, to change 36 units, 42 units, sorry. To change 42 units, you need a distance of 6 meters, correct? From plus 36 to minus 6, 42 units change, you need a distance of 6 meters. To change 1 unit, you need 6 upon 42. And if 36 has to be made 0, how many units change you need, guys? If 36 has to change to 0?
6.
No, if 36 has to change to 0, how many units change?
36.
36 units of change will take this much of distance, right, guys? Am I right? Correct?
Yes, sir.
And this will give us XZ. XZ will be how much then? 5.143.
5.143. 143.
143.
Has everybody understood calculation of XZ? If you have not, please let me know. As everybody, so you see from the graph, you can never read 5.143 here. And if there is an error in reading, then you will not have the BM becoming 0 at B. There will be some residual carryover. Now, if the graph is very complex and reading is the only solution, calculations may be more difficult, then yes, we'll read it also and we'll say, okay, we'll assign that to a reading error. But in such a case, there is no reason for us to just let that slip in. We can avoid slipping in of that error. So is the calculation of XZ clear to everybody, class? Now, if I subtract this XZ from XC, which is 6 meters, I'll get ZC also. How much is ZC?
857.
0.857 meters.
0587.
So is this calculation of the two bases of the triangles formed clear, beta? So now, can you please make the BM table for 6 points now? BM table, I'm writing in the brackets. Okay, SF units, guys, here I didn't write, please write it. SF units are kg. And here on the graph also SF in kg here. Okay, BM table by areas under SF diagram. And we'll have 6 of them now. Order has to be as per the SF diagram, class. 1, 2, 3, 4, 5, 6. Okay. 2, 3, 4, 5, 6. BM will be in kg meter class. The points will be A, then X, then Z, then C, then Y, and P. Please make sure the order is not messed up. Now, can you please fill up these values? It's okay. You can round off these values to one decimal place in the BM table, no problems.
नहीं sir.
No, no, no. There's something
Minus
like that.
55.997.
Okay, let me just check again. 19 plus 47. 2, we can multiply by 2. 132 minus 76. Okay. 56 plus 56. Minus 56, sorry. If I'm rounding off. Plus minus 56. Minus 56. Plus half base into height becoming 0. That is the BM, correct, Vita? So BM values are 0, minus 14, plus 78.6, plus 76, minus 56, and 0. If anybody is struggling at any of the points, let me know, class. Is the BM table okay with everybody, or anybody is still doing it? Please let me know.
Still doing.
Still doing it. Okay, confirm as soon as you're done. Done, guys? हाँ भाई लोगों, हो गया? Got the table?
Yes, sir.
Okay, draw the curve then. Draw the BM diagram. Please draw the BM diagram, whatever you feel appropriate, so that you can identify any potential mistakes. We are at the last step of doing the question, and then of course 2 values are required, which we'll figure out. Please look at the values before you decide where the x-axis has to come. It is plus 80 minus 60. So I need more on top and little lesser at the bottom will do. E X C Z. Sorry, this is Y, not X. This is Y. And Z. Somewhere midway here. X and A. 60 means somewhere here. If I take minus 60, 30, 10, 20, 1, 2, 3, 4, 5, 6, 7, 8, plus 80. It will be 0 here. You can plot the points and then we can join them together, no problem. Guys, once you've plotted the points, let me know, then we can join them together.
Done, sir.
Everybody is done? Anybody still plotting the points, guys? Okay.
Yes, sir.
To
Just a
join,
moment.
okay, let me know once you're done.
Okay, sir.
Okay. Look at the SF diagram, guys. What is the shape of the SF diagram from A to X? Only look between the points. Don't look the full thing. A to X, what is the shape?
Triangle from vertex to
From
base.
vertex to base. So it will be first near horizontal and then it will become steep. The curve would be somewhat like this. Am I right, guys? Yes or no?
Right.
Correct, sir.
Okay. Everybody is okay with A to X shaping? Okay.
Yes,
Look
sir.
at the SF diagram. What is the shape from X to Z?
Again, triangle with base to vertex.
From base
So
to
it will
vertex.
be first steep and then it will basically be becoming 0 somewhere here. So something like this it will become, right? Am I right, guys? Becoming 0 there, right? I've used a very small scale because I wanted to do it on the same page. Right? It will reach a maxima at Z. The rate of change will become 0 at Z because it has reached the vertex of the triangle. Then the next point, Z to C, is so close, though it's a triangle from vertex to base, but that it will be basically starting coming down. You'll not be able to appreciate much out here in any case. But if you were to appreciate, then yes, the triangle is from vertex to base. It will be first near horizontal and then steeper towards C. Guys, let's leave out C to Y for a while. Let's close out from Y to B or B to Y. What is the shape?
Triangle
B to
vertex
Y,
to base.
vertex to base. So towards B, it will be first horizontal and it will be steeping towards by Y. Will that shape be like this from B to Y?
Yes, sir.
Okay. Now, only thing we have to do is join between C and Y. The shape is trapezium. Okay, guys. Now, what is a trapezium? Let me go on the previous slide. Yeah. What is a trapezium? A trapezium is nothing but a combination of a rectangle and a triangle. So, if it was rectangle, it would have been a straight line integration. Triangle makes it a curve. So basically, it will not, the curve will not be exactly the same as for triangle, but whether it will be first the rate is less or more, it will depend upon whether you are integrating from smaller side to bigger side of the trapezium. Why? Because then it is like for the triangle, it is vertex to base. Or if you are integrating from the bigger side of the trapezium to smaller side, then the shape will be somewhat on the same lines as base to vertex. Of course, how much will be the curvature will depend upon also how much is the difference between the parallel sides AB. Because as they tend to become equal, the trapezium tends to become triangle, rectangle. And as the difference between them increases, the trapezium tends to go closer to a triangle. So you can only be guided somewhat by the triangle depending on if you're integrating from smaller side of the trapezium to bigger side, somewhat the shape, somewhat not exactly the same slope, but somewhat it will be a triangle from vertex to base. That means initially it will be the rate will be less and it will be increasing towards the longer side. And if it is from longer side to smaller side, first the rate will be steep and then it will get little lesser. It will not become zero the way it became for triangle, because for triangle it was hitting the vertex at zero. But for trapezium, there is always some side here. It is not becoming zero. So have you understood what I said before I go back to the diagram, guys? Yes or no? Clear, better? Guys, you have anything to ask on this diagram? Please let me know
Sir,
before I go.
जैसे पहले we were being guided by this property कि
There is no
almost
such
half the length
property. There is no such property for trapezium because it will depend upon what is the ratio between A and B and what is the spacing between them. Okay.
ठीक है sir.
There is nothing like so much percentage. Anyway, if you have any doubts, what you can do in rough, what you can do is, if you want, if you are still having problems, you can just calculate one of these areas and mark one more point. Yeah, that's all you can do at the most if you want to do. This height will be exactly half, base will be half, and you can calculate the area of another trapezium and mark one more point. But that will be waste of investment of time, and time matters in the exam. So if you want to do that, by all means you can do it. But the more questions you do, the need for doing such an exercise should be minimized or eliminated, preferable. So let's go back to our page. Yeah. Look at the trapezium from C to Y. Is it from smaller side to bigger side or bigger side to smaller side?
Smaller side to bigger.
So that means slope will be greater towards C, or slope the curve will be steep, more steep towards C or more steep towards Y. Tell me. It will be steeper towards Y or it will be steeper towards C. Steep curve shows more rate of change. Let
Towards
me
C.
give you
To-
Skipper
towards
to Y.
Y,
Towards
towards
Y.
Y, right? So
Two
that
Ys
means
in.
if I, yeah, so you can join from up or down. It comes like this. The rate is slightly lesser, but then it is becoming steeper at Y. So something like this curve will join here like this. So you see this is steep, this part is steeper. Here it is becoming slightly less, but not becoming zero. It is continuing like this. And now what do we get here? We get the BM diagram for this particular question. This red one is the BM diagram for this particular question. Now, if you have any questions to ask on shaping from C to Y, please let me know, because others were triangles, so I don't see much of an issue. If you have any questions on how to visualize the shape for the trapezium, please let me know. Now we have the question that find the SF at 2.55 meters from end B. Go to the SF diagram. Go to 2.55 meters from here. That means you want at 2.55 meters. I'm just writing for the sake of clarity. You need this value. Am I right, guys? Yes or no?
Yes, sir.
Now, of course, you can read from the graph, but again, reading from the graphs for such a simple case will never be as accurate as you can calculate. Guys, what is the value of SF at Y? 28. What is the value of SF at B? 0. What is the distance between B and Y? 4 meters. So, and is it plus? Yes, it is plus. So, guys, are they joined by a straight line? Yes. If they are joined by straight line, that means rate of change is constant from plus 28 to 0. So we can use the same concept which we applied here, unitary method. Over 4 meters of distance, shearing force changed by 28 units, 0 to 28. Over 1 meter, it will change by 28 by 4. Over 2.55 meters from B, it will change by this much. Am I right, guys? Correct?
17.85.
17.85 newtons. So by simple calculation, I can get the exact value. So the shearing force at a distance 2.55 meters from end B will be plus 17.85 kg. Is the answer for shearing force clear, class? Yes or no? Correct, Peter? If you read it from the graph, I think the best somebody can read is 17.7, 17.8, 17.9. That is the best you can read. Obviously, reading 17.85 from the graph can be ruled out. And if the graph is very small, then you may be struggling to read 17.8 also or 17.7 also. So, guys, if the question is simple, you can your compromise scale does not bother you. Somebody was asking me a while back, guys, if you have to read it from the graph, then scale should have been amplified because a bigger scale will reduce the error of reading because the least count of the graph will improve. But if you can calculate, then even this whatever I have drawn is good enough also if you don't want to use it for reading. But somebody may say, sir, what happens if it doesn't click me? What happens if I don't have time? If you don't have time, then read from the graph and say from the graph, SF at 2.55 meters from end B is 17.6 kg. Suppose you read 17.6 kg, give 17.6 kg as the answer. Don't worry. Complete your question. Is that clear, beta? Is that clear, class?
Yes, sir.
Then he also wants BM at 2.55 meters from end B. Look at the BM diagram and tell me, is the BM negative or positive at that distance? 2.55 meters from end B?
Negative.
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 So somewhere here, this distance is 2.55. If you don't have any time, go here and give the answer. BM is so much minus whatever you read. Give the value so much minus so much kg meter. But we can calculate it simply also. Guys, there are two ways to calculate. But you have to take the simpler one. What is BM at Y? A BM at 2.55 meters. What is the BM at this point? It is the area under the shearing force diagram, either to the left of it or to the right of it. Both areas will be same. So if you go from left up to Y, you have it minus 56. Right? Now you have 17.58. You can calculate this plus area and add to that and you'll get the BM here. Yes or no? Am I right, beta? This is a trapezium, this area. Correct, beta? Am I right? What is the area under the SF diagram up to Y? Area under the SF diagram up to Y is the BM at Y, correct? Am I right, guys? To the left of Y.
Yes, sir.
That is minus 56. Yes or no? This area 1 plus area 2 plus area 3 plus area 4, they all come at minus 56 here. Yes or no, beta, in the table? Correct?
Correct, sir.
Am I right? So from minus
Yes, sir.
56 to that point, what is the change? Plus area of this trapezium, whose one side is plus 28, other side is plus 17.5. The distance between them is 4 minus 2.55. Can you obtain it? Accurate value? Yes or no? Correct, class? Guys, have you understood or not? I'm not getting the response. I don't know then whether it is going in or not. Okay, it seems everybody has understood then. I'll take the benefit of.
Can't we calculate the area of the triangle, the last one, and subtract?
No, we can, wait, we can. I'll come to that little later, but people are used from left to right, so that is also possible the way I told you, Abhinav, yes or no? Okay.
Yes, that's right.
Now, the other thing is you can only calculate area to the right of the point in question. Area to the right of point in this question is this. So now you are coming to this point. You are coming from this point from right to left. Yes or no, beta? Yes or no? So when you come from right to left, mute yourself, mute yourself. When you come from right to left, positive SF will give you negative BM. You remember the sign convention will reverse now? Correct? Correct? So BM with the triangle, it is easier. I was to come to it later because many of you would then in the sign convention unnecessarily go for a toss. You can calculate the area here. It will be minus 1 by 2 into 2.55 into 17.85. And this will be the BM at this point here, minus so much. Somebody else may say, I'll calculate the value by triangle. I'll take the sign from the diagram. That is also possible. But if you're calculating triangle in a hurry, you should not end up writing plus value of the BM. BM will be minus at that point. So you understand the risk, Abhinav?
Yes, sir, understood.
Okay. So the risk is, as long as it's clear, you can go from left to right or right to left. Obviously, right to left is easier. But when you're going from right to left, the sign convention will reverse. Positive area of the SF will give you negative BM. And that is why you're getting this much of negative BM here. And you can calculate exact SF and exact BM at 2.55 meters. Now, another way of dealing with it is the way you people said. Could we have taken one more point here? Yes, you can take a point at 2.55, but that will unnecessarily keep adding to your working. So you can take that point and calculate. That's also okay on the run. You could have inserted one more point here and calculated. Is that clear, beta? But then it will form a trapezium and then you'll have to deal with the trapezium here, right? So you can do it in different ways. I do not see much sense in unnecessarily increasing the number of points at the onset when it can be conveniently handled at the end. But if you're not happy with handling it in the end, you can insert a point at 2.55 meters from end B and do it that way also. Samuel, does that answer your question also now?
Yes, sir.
That will unnecessarily make one more trapezium and then you will be going in circles. But if you are comfortable that way, please go that route. There is absolutely nothing wrong in it. It will, the table itself will answer your question at 2.55 meters, right?
Yes, sir.
Okay. So guys, this is January 22 question and this is a reasonably good question. I don't know what percentage of it has you have found yourself comfortable with, what percentage you are confused with. Now you'll have to review this question today after the class and based on your individual needs, and let me know tomorrow if there is any concern in this particular question, either shaping the BM curve or getting the BM. If somebody wants to do it again by taking another point at 2.55 meters, you can try that way also, you'll get the same answers. So there is absolutely, I'm open to it. You can do it whichever way it comforts you. Guys, you can review this question. I'll not stay on this question for any longer, and we can come back to it tomorrow. I'm not clearing any working. I'll retain it till tomorrow. I'll clear it tomorrow then. Okay, because I would like to take a couple of questions more before we call it off today. Guys, this is August 21. August 21. MMD. A beam of mass 61.162 kg, length 10 meters, rests completely on a flat support. A concentrated mass of 30.581 kg is placed on the center of the beam. Draw the SFBM diagram to scale. Simple question. Now, guys, here what has happened is the weights are given in kg. In the last question also, they were given in kg. There we prefer to use in kg itself. Here they are given awkward figure. If you multiply this with acceleration due to gravity 9.81, so you'll find that 61.162 will convert into 600. Can you multiply and see?
Yes, sir, correct.
And likewise, 30.581 will translate into 300. So if multiplying by g is simplifying the thing, you can multiply. So there is no hard and fast rule. Should you continue in kg or tons, or should you convert to Newton and kilonewton? It is all matter of convenience. Previous question we did not convert. This question we'll prefer to convert. Now please make a note of it here, that when you multiply kg, any value in kg with acceleration due to gravity, that is g, it will give you answer in newtons. If you multiply something in tons with meters per second square, this will give you answer in kilonewton. Is that clear, beta? Please be careful. Am I clear, class? Kg into acceleration due to gravity will give you the result in newtons, and tons into acceleration due to gravity will give you result into kilonewton. Clear, class?
Yes, sir.
Okay. So based on this, can you please now convert them and make the beam diagram the way you think appropriate? It's a MMD question. When I started my explanation of SFBM, I said your pen is resting completely on the table. So please recall that. That may help you in making the diagram. Okay, I have digitized it. Okay, I thought I didn't know that I've digitized. Guys, once you've drawn the diagram, let me know. I'll show you. Then I have the working here with me. Done? Okay. Guys, is this the diagram you have
Yes.
made? This is the beam of uniform cross section, 10 meters in length, AB. It weighs 600 newtons at the rate of 60 newtons per meter. Am I right?
Yes, sir.
Correct. It is completely resting on a flat surface and carries a weight at the mid length, is it? At the center, yeah. This is resting on this yellow one is the surface on which it is resting. And it carries a weight at its mid length of 300 newtons. Is this the diagram you have made? Correct, guys? You can use crossing.
Sir,
I'll use colors.
concentrated mass.
Yeah. What is the question, Ali?
Sir, ये concentrated mass को I did not put as a point force.
Why? What is the meaning of concentration, beta?
Yeah, I
Concentrate.
understand, sir.
Okay.
Yeah.
ठीक है, as long as the whole idea of doing questions is to basically figure out what all you're misrepresenting, right? So guys, you may have done it like this. You see, if I was to draw it myself, I will, since I would draw the beam like this, and then I'll draw the resting on it in a I'll cross it up separately like this. You can draw it like this. I have used colors because I have digitized the solution. Guys, is the question clear to everybody? This is mid length. Guys, how much will be the reaction? Can you tell me reaction? How much will be the reaction?
900.
Okay. Is it acting at select points or is it acting all along the length? Look at the
All
diagram.
along the length, sir.
So all along the length.
So like uniformly distributed weight, this is also uniformly distributing upwards. So you have a reaction of 900 newtons acting at 90 newtons per meter. Am I clear, class? Does everybody agree?
Yes, sir. Yes.
Guys, how many minimum points for SF diagram? Now look at the diagram and tell me, beam diagram and tell me.
3 points.
Two. 3 points.
3 points. Please make the table for 3 points then. You were missing out on 2 points, but 3 points you corrected, so it's okay. SF will be in newtons. See if any cell is to be divided and fill up the table, please. Like Ali missed out on concentrated. If you're making mistakes, you should be able to figure out. Otherwise, if you keep seeing, you'll feel, yes, this is what you would have done. Once you're filled in, let me know. I'll show you. It's all there with me ready. I'm holding it back. Done, guys? Filled up the table?
And sir.
Yes.
Bhai, your time is getting wasted. You have the exam. So if you are genuinely doing it, then only, otherwise you should be more interested than me to cover as much as possible. At A, the shearing force is 0. You only have to divide C because C is the only one carrying concentrated load. From A to C, I'll not speak anything unless somebody needs my support. Are these the shearing force values you got? Yes or no?
Yes, sir.
Ali, did you get these or you messed up somewhere?
No, 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 sir. I got it.
Okay, very good. Samir, how about you? Did you get these values?
Yes, sir. Got sir.
Okay. Guys, if you've got these values, can you make the SF diagram, please? Make the SF diagram. Now I'll hold here. I've drawn the scale. You can take plus 150 anywhere and you can take minus 150 anywhere with same distance on the other side, and now draw the SF diagram.
Done, sir.
Okay, very good. Very good. Very good. Very good. Is this the SF diagram you got, guys?
Yes, sir. Yes, sir.
Okay. Both the changes from A to C, one is the weight of the beam, other is the reaction. Both are uniform. Therefore, A to minus 0 to plus 150 joined by a straight line. And so is the reason for joining minus 150 to 0 with a straight line. Correct, guys? Guys, how many points required for the BM table now?
3.
Please make the BM table then. Anybody still struggling with the SF diagram? If not struggling with SF diagram, please get the BM table in place and write down in the brackets by areas under the SF diagram. And BM will be Newton meters this time. It was kg meter in the previous question. Here it is. Are these the BM values, guys, which are on display?
Yes, sir.
Then draw the BM diagram. And this MMD question is done. It's a simpler one, but definitely a MMD question.
But if you didn't solve it for this 9.8, and then it would have gotten a little complicated.
No, so that's the whole idea of picking up these questions, Samuel. That's why we are picking up these questions from the past paper so that all these issues get addressed, right? So each question has been picked up with an intent that it is clarifying something, right? We had a trapezium coming up in the last one, then we had the values at 2.55 meters. We used them in kg, and now we are converting kg into Newton, or tons could have been converted to kilonewtons.
Yes, sir. Yes.
Sir,
So
while
don't get,
sir, while making this BM diagram, can we make it overlapping each other, like SF and BM diagram together?
beta, usually your lodicator gives like this, but lodicator is a software. You can make it, but both scales are different. You'll get confused yourself. One is both scales don't have to be same. SF will have SF scale and BM will have BM scale, right? SF scale
Yes,
is
sir.
in newtons, BM scale is in this case Newton meter. So scales are different. So you'll have to have two different scales on y-axis. You'll get confused yourself, right?
Okay, sir, understood.
हाँ,
Actually,
there's no
indicator में वैसा ही आता है ना,
no
same.
lodicator में आता है because lodicator is a software driven thing, and then it gives you the values, right? Which are
Yes,
superimposed on the curve, right?
yes,
Correct.
sir.
But
Correct.
there is no harm in superimposing, but you'll get confused because some people will say, should I keep the same scale? No, why should you keep the same scale? You have to have different scales. They represent different things, right?
Yes, sir, correct.
Only the length scale can be same, nothing else. So before you said lodicator में same आता, I said lodicators, yes, it gives you the same thing. The BM diagram, guys. You see, guys, now before I show what I have done here, what you can do is, if you have a problem, now 375 I have randomly marked. If you have a problem, what you can do is at C it is plus 375, and this 375 thing you can divide into 4 equal parts. Okay, don't I give any explanation, just that is to facilitate. The triangle from A to C is vertex to base. So at the mid base, it will be only 25% area, right? So I mark this here point. Okay. Likewise, from B, this will be 25%. From B, this will be 25%. And now automatically my shape will take the curve. You see, it will be easier for you to shape if you're not comfortable with it, the other methods, right? The curve would be like this. Understood, guys? Am I right? Have you understood, beta?
Yes, sir.
Yes, sir. Yes, sir.
Okay. I'm showing the curve that is already on the digital form, but here I've explained to you how to draw it. You see, the curve will be like this. Correct? They are mirror image on each side. Am I clear, beta?
Yes, sir.
Okay. So if you want to take a screenshot or something, let me clear and show it to you. Did I delete the previous one also? Chalo, anyway, if need be, I'll explain tomorrow. I'll seek from you then. That's the rubbish thing which happens sometimes. Yeah. If anybody wants to take a screenshot, or I don't think this is much simpler than the previous one. Am I right?
Yes, sir.
Yes, sir.
And don't unnecessarily get panicky about small issues that every question it is changing. Guys, questions have been picked up with changes. So don't think that, you know, it's very difficult. Every question we are having something. The questions have been picked up to cover the wide range of variances which they are bringing in. That's all. And it's, but fundamentally everything will remain same. Guys, I have digitized this also. Would you like to do this? Make the diagram. What is the time? Let me do this question with you today. It's 11:56. Yeah, let's do it. Why? Why not? Do it. Make the beam diagram. Once you're made, confirm. See whether you want to continue using in kg or do you want to switch over to newtons and kilonewtons, whatever it may be. Take a call. Once you make the diagram, let me know. I'll show you. It's digitized, so for me it is easier. I just have to click the computer.
Done, sir.
Done? Okay. Are these the points required for SF table? Yes or no? 1, 2, 3, 4, 5. Am I right, guys?
Yes, sir.
Please make the SF table for 5 points. Then calculate the reaction. Calculate the reaction first, and then make the. Let me know what the reaction is coming. How much is the reaction, guys? If anybody's got. Class reaction, reaction.
85.
70 and 85.
70 and 85, guys. So if you have got them correctly, then can you please proceed with the SF table? Proceed with the SF table then.
90 and 85.
90 and 85.
Yeah, so that's what I'm saying. No? Where are you making it, mixing it up? I have it with me. It's 90 and 85. 90 on the left side. Correct, class?
Yes, sir, that's
Yeah. Okay. Please meet the SF table. Haji, got your SF table completed? Are these the values? Please confirm. Yes or no? Guys, SF यही आया. Please confirm.
हाँ सर ठीक है.
Okay. Okay, anybody still completing the table and wants me to wait? Then make the SF diagram, guys. Yeah, tell me. Somebody was saying something. Please go ahead.
Yes, sir. Sir, please wait, sir.
Okay. Yes, how far have you reached, Samir?
Yes, sir. Complete हो गया acceptable.
तो करके बोला करो ना बेटा, एवरीबडी इज वेटिंग फॉर यू. यू कंप्लीट करके तुम भी बैठ गए.
Okay, sorry, sir.
Okay, guys, draw the SF diagram.
Done, sir.
Done, very good. Draw the SF diagram, guys. I have taken it at every whatever he had said, because in question he says take at that. If you don't want to skip with these, you can skip. So anyway, doesn't matter. So because something is said somewhere. Okay, never mind. So I have calibrated the y-axis, and then I'm sure this is what you are getting. Correct, beta?
Hanji, sir.
Correct, sir.
This is the SF diagram you get. Obviously, for BM, you will need one more point, guys. Yes or no?
Yes, sir. जहाँ पे वो
Yes, sir.
एक्सेस को आ रहा है.
Can you calculate dx and xe class then? Dx and xe? Please calculate. You already know. Samir, you can continue drawing your SF diagram, beta. No problem.
Yes, sir. Yes, sir.
Yeah, draw your SF diagram. No problem.
One point five
Okay.
dx.
Very good. Very good. Very good. And the other will be then 8 minus the 6.5, right? Right. Why? Because you'll need these bases for calculating the BM beta. Those who are done with the diagram, they can continue with the BM table.
BM table done, sir.
Done. Very good. Samir, how far have you reached?
सर BM के प्रॉब्लम निकाल रहा हूँ सर.
निकालो. Very good. ये calculate हो गया था dx and xe. You could calculate.
Yes sir.
Okay. Very good.
हाँ ठीक है सर.
Okay. Okay, guys. Here is the SF diagram then. Sorry, BM diagram. My mistake. Something like this, you would have got the BM diagram, guys. Yes or no?
Yes, sir.
हाँ जी.
Right. Now he wants the point where the BM is nil between the load at D and point B. That means he wants to know the location of this point. Correct, beta? Am I right? This one. Correct. The question wants that. I'll remove this if you're not able to see the question. Now, can you see the question now? Calculate the point on the beam between the load and the end B where the BM is nil. So BM is nil here after C also, and it's at nil, 0 before E also. Question wants the location of point, this point to the left of E, right, beta? Am I right? Do you agree,
Yes.
class? Okay. Now, guys, one thing is, if you are short of time, please give this distance from the graph if you are short of time. Okay. If you are not short of time in such simple cases, again, you could consider calculating it, provided you are comfortable with calculations and you have time. Okay. Nothing should be done at the cost of time and all that, because some little inaccuracy here and there, you may lose some marks, but at least complete. So whatever you read from here would be okay, but obviously it will have some errors because of the scale issues. Now somebody may want to know, sir, how do I calculate this point? Guys, we are talking of BM at this particular point somewhere here. This is the point we are talking about, right? BM at this point is 0. What does it mean? That means area 1 under the SF diagram plus area 2 under the SF diagram plus area 3 under the SF diagram plus area 4 up to this point. The algebraic sum of these areas is 0. That is why the BM at that point will be 0. Do you agree with me? Yes or no? Correct, class? Am
Yes,
I
sir.
right?
नहीं सर एक बार प्लीज रिपीट करेंगे.
If the BM is 0 at this point Z, which is Z here, then what does it mean? When the BM is 0, what does it mean? How are you calculating BM in the BM table? How are you calculating BM in the BM table?
By
Area
calculating
under
area.
the SF curve.
So that means if you add all the areas to left of Z under the SF diagram, they should be 0. Then only at Z the BM will be 0, correct? Yes or no?
Correct. Correct, sir.
Okay. In your table, you already have the area, the BM at X. BM at X is plus 191.25. That means area 1 plus area 2 plus area 3 is plus 191.25. Am I right? Correct? Correct, class?
Yes, sir.
Akshay, right? But for BM to now become 0 at Z, that means this area which I'm shading should be equal to minus, so it's already there. It should be equal to 191.25. Then only the BM will become 0 at Z. Am I right, guys?
Yes, sir.
Yes or
Correct.
no? Guys, for BM to become 0 at Z, this area which I have shaded under the SF diagram, this should be equal to area up to X, and up to area, the up to area up to X is the SF at X, BM at X, and BM at X is plus 191.25. Am I right? Yes or no? Correct, guys?
Correct.
Okay. So, and what is this shaded area? It's a triangle, so it's a simple one. So therefore, I'm resorting to calculation. Otherwise, I could have used the graph. Now, let us say this distance from X to Z is X centimeters or X meters rather. Okay. If this distance is X meters, then we'll find the height of this triangle, this one. How will we find the height of this triangle? From X to E, the height is changing from 0 to minus 65. Over how much distance? 6.5. So, over a distance of 6.5 meters, height is changing by 65 units. Over 1 meter, the height will change by this much. And over X meters from of distance, this will change by this much, which is equal to 10x. Am I right, guys? Yes or no?
Yes, sir.
Correct? So the height of this red triangle here will be 10x. Okay. So now you want this area of the red triangle to be equal to 191.25. And what will be the area of the red triangle? Half. Base is x. Height is 10x. Since it's a simple case, we are calculating it. This should be equal to 191.25. This gives me how much x value, beta?
6.185.
6.185. So now you can give that distance because now you know from end A, the distance will be how much? It will be distance up to x plus this 6.815, or you can subtract it from 6.5 and give the position of this. So basically, where will the BM be 0, the point he's wanting? It is at a distance of 6.185 meters from X. From this point, somewhere here, the BM is becoming 0. So you know what is the distance A to C. You know what is the distance A to D. You know what is the distance D to X. All that you know. And to that, you will add another 6.185. You'll get the distance from end A. If you want to give from end B, you can give from end B. Choice is yours. But have you understood the method of calculation in case you want to get exact answer? Yes or no? Because graph will never give you this 3 decimal place accuracy. Correct, beta? But again, I'm saying, you see, you can see my graph in the background. When I did digitize them, I use the graph in the background, guys. So it's not that these diagrams are randomly plotted. There is a reasonable accuracy in the shape of the diagrams. You can see the graph at the background of the question. I've used the graph in the background to plot the values to reasonable accuracy. Okay. So what I'm saying is, if you have to calculate and if you decide to calculate and if time permits to calculate, will you be able to calculate the distance now? Yes or no?
Yes, sir.
Okay. So let me see whether I've calculated here or I've just given the answer. Maybe I've just given the answer. Yeah, I've just given the answer. I have given the answer from the graph, of course, but you can calculate if you want. Yeah. It's 2.35 meters from end B. If I bring the graph in the background, this will be the value from the graph. And if you calculate, how much did it come, guys? You got
2.31, sir.
2.315. Now 315 I
What?
can't
Three
read from
one
the
five.
graph. Yeah. So reading from the graph, I can't read 315. Best I could have read from the graph was 2.35, which is also a good answer. So if you don't have time, you can read from the graph and give. If you have understood how to calculate and you wish to calculate in simple cases like this, you may calculate. Okay. But if you're not able to calculate, don't unnecessarily pressurize yourself beyond a point. Because it should not happen that just fighting for these 2, 3 marks here for accuracy, you end up messing up your other things. So guys, you'll have to make a judicious call. If you are good in calculations, if you are fast in calculations, if you have understood, you want to go by accuracy, by all means, preferred. But if you are struggling with accuracy, if you are not very comfortable with square, and because if it was a trapezium, then it will become a quadratic equation, then it will become very difficult. Then I don't suggest people to use the mathematical route. Then I always suggest take the graphical route. Okay. But here, since it was a triangle being formed, so therefore I said, okay, you can use it and finish it off. So guys, it's up to you how you want to basically do this particular thing. Okay, so that is the answer to this question, May 2019. If anybody wants to take a screenshot, let me move the thing. You can take a screenshot now if you so desire. Okay. Okay, guys, I think we are already overshot, but I'll just take 5 minutes for this. Or you can try this question. This is like that 50 Newton, that second question we did yesterday, and today we drew the graph. Only thing is, there we had 50 Newtons, the weight of the beam given. Here, the weight of the beam will be W into L. It will not be 50 Newtons. So you'll be solving it in W and L. Can you understand here, better? The second question that we did yesterday, where there was a beam of uniform cross section of length 10 meters. So there, the value of length was given 10 meters. Here it is not given, it is given L. Weight was given 50 Newtons yesterday and supported at its two ends. Draw the SFBM diagram. So the shape of the diagram will come the same. Only thing is it will come in terms of W and L. It is November 2017. It was one of the parts. It was not a 25-mark question, guys. It was a 12.5-mark question. What can you do? You have this beam, length L, weight W into L, because it is W per unit length. So total weight will be WL. It's of uniform cross section, supported at the ends. Let's say A and B. RA will be WL by 2. Am I right, guys? Yesterday it was 25-25. Yes or no?
Yes, sir.
Yes, sir.
WL by 2. We can make the SF table for 2 points or 3 points, whatever you want, minimum 2. So I'll stick to 2 only. Today also we did SF table. You can write the full things by yourself. I'm not writing complete things here now. SF in no units are given, so it will be the unit of W, unit of weight, or you can say here. Okay, and we'll have only 2 points, A and B. Both have point forces. They'll be divided. To the left of A, it is 0. We carry forward 0 plus WL by 2. So here it becomes plus WL by 2. We carry plus WL by 2. We have minus W full weight, making it minus WL by 2. Minus WL by 2 plus WL by 2, making it 0. Do you agree, guys, with these values of SF coming at these 2 points? Yes or no? Am I right? Correct, guys?
Yes, sir.
So the SF diagram would look like this. A, B. You'll take some distance and mark it as plus WL by 2. Same distance, you'll mark WL minus 2, WL by 2 minus. There we had marked plus 25 and minus 25. So what will be the SF diagram? It will go from 0 to plus WL by 2. Then it will go to minus WL by 2 like this, cutting at the mid length and then becoming 0. This is C, this is L by 2, and this is L by 2. This is the SF diagram. Do you agree with me? Correct, Peter?
Yes, sir.
So what are you doing? Basically, instead of putting 25, you're using WL and notation. So I'm sure you'll agree 3 points for BM, guys. Yes or no?
Yes, sir.
So BM table. BM units will be product of length and weight. ACB 0. Then plus triangle. Plus triangle will be plus half. Base is L by 2 into height is WL by 2. It becomes WL square by 8 plus W8 square. WL square by 8. It becomes plus WL square by 8 minus the triangle becomes 0. Now you'll draw the BM diagram, guys. It's only plus, so no need to have anything below the x-axis. You have A, you have B, midway C. You can take any scale here, WL square by 8. So it's 0 here, it's WL square by 8 here, it's 0 here. First triangle is from base to vertex, like this. And this will be mirror image of it. This is the BM diagram. It is exactly like that question of 25, 10 meter long, 50 Newton weight. Same shapes. You see the shape of the SF and BM is same. Only thing is the values are not given. They are given in terms of W and L. Correct, Peter? Am I right?
Yes, sir.
Is it okay, class? Have you understood this? Don't get confused that W and L, what to do. It's W tons, W units per length, per meter length, or whatever per unit of length is the weight. So guys, if you see the sheet that I had sent to you yesterday, if you see the sheet I had sent to you yesterday, let me open those questions also if they're here. Let me just open those ones. Let me keep it here. Is it in the end? Yeah. Guys, this is what I had shared with you yesterday. Now, all the 4 questions in the upper row have been done in the class. Can you see all the 4 questions have been done in the upper row, beta? MMD January 22, August 21, and May 19, right? Then
Yes, sir.
in the lower one, MMD November 17 is done. The next two questions are based on concept of cantilever. I have shared a video with you. Please watch that video. This question and this question. They are based on concept of cantilever. I've shared a video with you. Please watch it today, definitely. And if you need to watch it twice, watch it twice. The third question I want you to do at home and come with that tomorrow. Okay. So the last question in the bottom row. So that means for tomorrow, we'll have only these 2 questions and one more May 23 question I'll do additionally. So we'll do 3 questions more from beam and cantilevers tomorrow. They'll be primarily cantilever questions. So can you please complete this last question, beam of uniform cross section, this one, and also watch the video, please, and review these questions. We have done all these 4 and we have done this one, guys. Correct? Yes or no?
Yes, sir.
Okay. So this is done. Let me change to marker, and so there is no confusion in your minds. You can have them again. If you have a doubt, let me know tomorrow. You can come with your doubts. That's not an issue. So this is done in the class today. This is done. This is done. This is done. This is discussed just now. Okay. This you need to do homework. Keep. Okay. This you need to do as homework. Okay, and this we'll do tomorrow. These are cantilevers, so we'll do tomorrow and tomorrow. And I've shared a video. Please watch the video on cantilever. So only small things to tomorrow, guys. I'll be maybe winding about 15-20 minutes ahead of time because I'll be traveling back to Panchkula tomorrow. Okay, so let's connect at 9:30 sharp. We'll start at 9:35 for sure, and we'll cover as much as we can. So see you tomorrow, guys, 9:30. Then please review them, and if you have any doubts, please feel free to